This video shows how I modified this ordinary kayak for sailing. Attachments and supports for the sail, the rudder, and the centerboard are all made from PVC and polyethylene pipe. This is 400 psi PVC, 1 1/4 inch and 1 inch. It's stronger than the regular PVC pipe and sold in all the hardware stores.
1 inch PVC fits inside of the 1 1/4 almost perfectly. Same with the polyethylene. And this is the 1 1/4 inch polyethylene irrigation pipe. You can buy this in the hardware stores. It's a little tighter fit. I don't know if you can buy this anywhere, but the utility companies use this for conduit, electrical conduit. And I found this piece laying along the beach.
This tool is a plastic welder. This is necessary for working on the kayak.
This particular type of plastic welder is airless, and it's more like a soldering iron than anything. It's only a 40-watt model, and if I was to do this project again, I'd get something with some more power. A hot air welder would be better for this type of a project. I will demonstrate the airless welding iron on this piece of polyethylene from a garden sprayer. I'll start by tacking it down. Just to temporarily hold it in place. Discard the first inch or so. Burn. Clamp's not holding. Smooth the edges down if you want. You can use the welding iron to repair scrapes and dings. Most household items are marked on the bottom with a triangle symbol showing what type of plastic it is. This is grade 2 high density polyethylene, so this would stick to our polyethylene kayak if you wanted to use something like that for whatever. This isn't marked, but this garden sprayer is polyethylene. It's probably about the same density as the kayak, and in my case it's about the same color too. And plastics are colored by dyes that are added to it when it's first formed. You can't paint lower density plastics like polyethylene. It won't stick, it'll flake off. This is called JB Weld. It's a 2-part epoxy, and it's about the best adhesive you can use for a project like this. Adhesive, including epoxy, does not stick well to softer plastics like polyethylene, but it does stick well to metal and hard plastics like PVC.
The rudder and the centerboard are made out of scrap aluminum I had available, and 1 inch PVC and epoxied using the JB Weld.
This is a centerboard.
This allows you to continue to sail forward when the wind's blowing from the side, and you can sail into the wind by tacking. A pin made from a piece of wire holds the centerboard in place.
The base of the centerboard mount is reinforced with polyethylene from a garden sprayer that I found washed up on the beach after a hurricane. It's pretty heavy duty stuff. This was a difficult weld job to get to the back, so it's mostly just welded at the bottom. This wire coil down in this opening in the seat holds these pins good and snug so they don't fall out if the kayak tips or when you're loading and unloading. Stay in there. I haven't lost any of them yet. The rudder mount is the black polyethylene 1 1/4 inch pipe. It's welded on and blended in. This orange conduit, which is more rigid and stronger, would have been better if I would have had it when I first built this.
This simple design doesn't really allow for enough travel in the rudder, but it works. I might try to change it in the future. The rudder control handle is a piece of the black polyethylene pipe that I heated up and then formed to fit in this groove along the edge of the kayak, and it slides back and forth. I welded on a piece of the orange conduit for a more comfortable hold, better grip. And the link is just a piece of rope that goes all the way around the edge of the kayak and ties on to the rudder. This hardware was bought at the local boating supply store.
The mounts for the paddle are pieces of the black polyethylene pipe.
Since they stick out, they get damaged easily, need to be re-welded. Pedal fits right down in there, nice and snug, stays put. The sail is made from a poly boat tarp and 1-inch PVC, and the mast has a wooden reinforcement. It's a rake handle down the center.
The edges are reinforced with a weatherproof polyethylene tape tied on the string. Everything just slips together. Here's the mast base. I used an aluminum plate and half of a 1 1/4 inch PVC coupling, epoxied it down. This is polyethylene weld, very strong. And up here,
this mount was made from a piece of aluminum bar that was bent and hammered around a 1 1/4 inch pipe, and it was heated and melted into the plastic, and more plastic welded around it, wire wrapped around it, make a nice snug fit for the mast base.
fits down into that coupling. If I would have had this 1 1/4 inch polyethylene tubing available when I first built it, I would have made all of these supports out of this. And that's pivots on the base piece. The boom attaches to the mast with a reinforced PVC T-fitting. And I put a slight bend by heating this with a hot gun. Sail comes apart easy. All the sailing rigging comes right off, and it's ready for regular paddling.
Now I'll demonstrate the sailyak on the water. Here we are amongst the small islands in the sound along Fort Walton Beach, cruising along with about a 7-mile-an-hour wind out of the south. Sailing in the reach positions with about a 10-mile-an-hour wind, I get about a 7-mile-an-hour forward speed. The rudder control is simple, very easy to use. The wind is now about 5 miles an hour out of the south, so I'm getting about a 3-mile-an-hour forward speed east and west. This wrecked boat is called the Misbehavin'. It's been on this island since Hurricane Dennis in 2005. Total sail area is about 29 square feet, so it'll heel over pretty good in a strong wind. Keeping balance without an outrigger can be a challenge, and this mast flexes, so a stronger aluminum or carbon fiber mast is the next project. Here I'm sailing to the west. I'm going to turn into the wind and point towards the southeast and tack upwind. And that's it. Thanks for watching and happy sailing.